Hello, good afternoon, everybody. So I'm going to talk about time frequency analysis applied to the study of oscillations in star, including the sun. So at the beginning when I met Alan, when I was beginning my PhD with Alan as a supervisor, by this time we had one beautiful data set, the IFIR data, made of 150 days of intensity measurements of the sun during a flight cruise from the Earth to Mars. And then Alan, with in mind the preparation of golf, well, he said in his typical French, well, we should be able to do better than the classical Fourier transform. Then it took me some time to get an answer, but finally I could find an answer in my typical English. Yes, I think a good idea would be to do some time frequency analysis of the signal we have. So what is it exactly? So one more spectrum today, but as we saw before, it's not the anatomic spectrum, but the acoustic spectrum of the oscillation of the sun. And so the idea was just to take a slice of the spectrum and to use a sliding window in time, and in doing this to get some temporal information on the behavior of the modes in time. And so you can see here during the 150 days of observation the variation in power of this mode made of two components. And in fact they are very close and they show a different behavior. So everybody was not convinced by this because one problem when doing this is the influence of noise. So we used completely different data sets, but simultaneous. So again, IFIR, which is so space-borne photometric measurements of the intensity of the sun, and also ground-based Doppler measurements of the oscillation of the sun. And then you see the same along the same period of time of 50 days for the same mode. You see again that these two modes have the same behavior. Both in photometry and spectroscopy. So yes, it was a good idea to do this kind of analysis. It was possible to do it, and it was a confirmation that the solar modes were stochastically excited. Then, much time later, 15 years later, another instrument was launched and put in orbit. It was Corot, and it was doing for stars what IFIR was doing for the sun. So looking at the intensity variation with time of the stars. Among Corot targets, there was Beta Cephei star. These stars are well known to show very large amplitude oscillations, but with the quality of Corot data, we could see that there were some smaller amplitude modes with complex structure. So the question was, this structure is due to several very narrow modes with very close frequencies, or is it something like a stochastically excited mode like in the sun? And so to find the answer, we used again time frequency analysis. You have here one classical large amplitude oscillation. So it's not at all the same excitation mechanism. It's an opacity-driven oscillation with very large amplitude and constant amplitude in time. And just beside, you have this behavior for in the same star. You have modes showing this completely different behavior, which is typical from stochastically driven oscillation. Again, some people were not convinced. They were thinking that this structure could be made of several narrow modes with very close frequencies. And so you have here several examples. Again, a solar mode. Here, the opacity-driven, so with constant amplitude mode in this Beta Cephei star. This same star showing stochastically excited mode. And here, another kind of star, delta Scuti stars, which are known to show opacity-driven mode with close frequency, and you see the beating, I hope it's clear, at least it is for me, the beating structure here, which is different from this one, so showing, in my opinion at least, that we really deal here with stochastically driven oscillation in this beta Cephei star. Just a word about why it's interesting. These stars are much more massive than the Sun, and if you can observe stochastically driven modes, you may measure the damping time of these modes, and it varies a lot. Let's look just at this solid line and this dashed line. In one case, you have a 10 solar mass, which is quite young because the amount of hydrogen in the core is quite high, 0.7. So you have a young star here. And this is the same star, but at the end of the main sequence, it's here, when the content in hydrogen is almost over. So it's the end of the main sequence of this star. And so by measuring the width of these modes, you have an information about the age of the star. Another example of the application of this initial idea of Alan, among Corot targets, there were also B stars with emission lines, so BE star. Again, a spectrum with, for example, 2 large amplitude here and other oscillations, mainly at low frequency. If you do, again, time frequency analysis to see what was the temporal behavior of this oscillation, here is what you get. So you see here the two, let's say, higher frequency components, which shows at the same moment decrease in their amplitude, and maybe at the same time an increase of the amplitude of the lower frequency modes. And it's particularly interesting if you look at the light curve of the star, so the intensity of the stars versus time. And we were very lucky because during the observation run, this star show an outburst. These stars are famous for this. Regularly, but randomly, they show some outburst. And this outburst in intensity, just before you have a precursor phase, which is characterized by a decrease in intensity. And if you compare this behavior in intensity with the behavior of the modes, of the amplitude of the modes, so again here the intensity variations with a different smoothing, and here the amplitude of the lower frequency modes. So you see that this outburst, which is certainly due to some ejection of material, is certain, well, we don't know if it's initiated by these oscillations or if it's only the consequence of another phenomenon, but clearly you see in the oscillations a signature of the, I'm almost finished, a signature of what will happen in the general behavior of the star. My conclusion, which is not a conclusion but a confirmation, we already knew that Alan has good ideas, and moreover, they last a long time. Thank you.